Okay. Yep. So today is the last lesson in Python. We'll be getting to the kind of project that was alluded to in the last handout at the end of last lesson, in which we can build like an encryption function in Python to, build a little code and then decode it. That'll be a kind of big project we have in the middle of this. But we have one last basic to kind of get to, just to kind of build up the Python foundations. You can see it labeled on the title page. So we'll kind of skip the project, get to the last new content, and then at the end of the class, if we have time, we'll go back and finish the project, or at least lay out all the hints and things to kind of get you going to finish it. And obviously the solution will be included as well. Again, just to remind us, we'll be using the shell in Replit because, again, we probably want to make a new file today, so we don't have everything in main.py, and this run button up at the top just executes the main.py code. So we'll go ahead and make a new file to begin, put all of this week's content in it, so we can divvy it up a little bit like that. I have all the basic instructions on these two slides. So we'll come into the shell, this ls, to list kind of the level that I'm at in my file management system. So ls, and then I can use the plus button to make a new file in the GUI, or the graphic interface, on the left-hand side. But if I want to use the command line interface in the shell to kind of do the whole thing, I can use the touch command. And touch basically means make a new file with the following names. I can say it's touch, and then name my file. And then I can make it like that. And then I can, do a lot of stuff in the shell that you can do just by clicking with the mouse on this side. So we have my file. Let's just go ahead and check it again. So I'll put, a single Python command in it. We can tell, oops. Again, when I click the run button, that's not going to do this open file. It's going to go back and do my main.py file. So we'll come to my shell. Again, ls to see that I can see the file that I want, and then Python name of file.py, and then that'll be how we execute the code today, as with last class as well. So that's the shell. And this is what you'll be using anytime you basically go beyond a cloud-based or website-based IDE, the thing that runs the code in any language. So if you go on to download something on your own laptop to run all the code and stuff like that, a true IDE. Not that this one is shabby, too shabby, but if you go on to do that, you'll be using the shell exclusively almost. So it's good just to get used to the basics of how it's actually done most of the time. So a little bit of review of last time. We did strings, and the big thing besides how to make a string and how to concatenate in them and things is, and let me zoom in a little bit or maximize it, is the indexing. And we can do this with both strings and lists. And what indexing is, just to review, is how to basically count the positions of each element in a list. We can see this is a list of the rainbow. And so we can see each one is labeled with basically a position that we call it an index, or an index position in this list. And we could do the same thing with a string, just each letter in the string. And the two main things, besides just knowing that we can count the positions, so we can get to a specific point in a list, grab the last element of a list, split something in half, is that in Python and in most coding languages, we count from 0. Python, like most languages, is 0 index. So instead of beginning at 1 in the strings and the list, we can see that we began at 0. And then what we would typically call item 2, or the second item, is actually index 1. So that's the main thing, begin at 0. And then even though, on top of this, even though this string is 5 characters long, even though this list is 6 items long, we only get to 5 because since we backtrack to 0 instead of beginning at 1, we also get to 5 instead of 6, which would make sense if it's 6 items long. We would typically think the last item is item 6, but we also move it back by 1 because we also backshifted the front to begin at 0. And one of the reasons that we begin at 0, besides a lot of convenience in the math and things that you'll eventually see, is that we can also negative index things. So we can begin counting and get to a point in a string in a list beginning at the end and moving up to the front. And we can do that just by using negative index positions. And in this case, it is exactly kind of what you would expect. The last thing is -1, and then you move to -5, and the whole thing is 5 long. So that kind of makes sense. But the negative indexing doesn't begin at 0. And that's like that's why we explained last time, because if we had 2 things labeled with an index of 0, both the beginning and the end, Python wouldn't know which way you want to do things. So one of them has to be index 0, and then this is index -1 if you want to go back to front. And then we see a nice continuum if you want to use both positive and negative indexing in doing math and things. We go -5 to 1, 0, and then on to 1, 2, 3. And we have a complete continuum, so we can consistently index into the individual elements in a list and a string. Last time we applied that indexing. So if we take a look at what we did last time, this looks a lot like the range function, in which you had something to begin at, something to stop at, and the step. We can do the same thing with a string and a list to pull something out by itself. So let's go ahead and just see that again. So if I have my hello, we'll print out a couple things. Come in. And we can see if you just print the name of an object, so this is my data object, which is a string. If you just print that, you print the whole thing. And once you apply this indexing notation, that's when you can begin to pull out the individual elements. With this, it's just a single element that you pull out. And then if we do the full gamut, we can do, the beginning, what we want to go to, and the step like this. And then we get, what we want. So we can see we begin at 1, which is the E. We go until this, and then we count by 2. So that's why we get the EL. Begin at 1, count by 2, so it's E, and then we skip to L. And then we don't include the stop, so we actually don't go to this, or we don't go beyond it, because we have that stop. So this is why this gives us, from this, just EL like this. So that this all can take a bit to get used to, just because it's a slightly different way of thinking, and it's a bit, complicated, the notation and just getting used to it. But we'll use it a whole bunch in strings, in lists, and with the range function, and with loops. So you will be using the same thing again and again. So if you haven't gotten used to it yet, you will eventually get used to it. And then we have all these examples again. This is what we ended with last time, kind of the usefulness of indexing. We had this example of having a list of email addresses that maybe you have just in a spreadsheet, in a CSV file. Maybe you web scrape it off of a website, and you have something that looks like johndoe@company.edu. Well, now we have the skills to take john.doe@company.edu, use indexing to find the position of things like the @ symbol, and then we can split it up using indexing. So we can take that and just get john.doe. Then we can use all these new functions that come built in, the index function. We can use the split function to say, take john.doe and give me back as a list John and Doe as 2 items. So then we kind of take the whole thing and begin to split it up. And then we have this last little bit that we did last time to take John and Doe, index the J and the D to capitalize the names. And then we use indexing to take the OHN and the OE to stick it back on to the capitalized J and the capitalized D to make a capitalized name. And then we just recombine them to get John Doe out of this whole thing. And we saw the usefulness of this once we have one email address and we have a function that can kind of handle that type of problem, we can just as easily take a list of as many email addresses as we want in the kind of same trend, name.name at something.com or .edu, and we can just spit it into a loop like we have down below. I just set up a loop, email in emails, get back one email at a time. Then I can call my get names function, spit in my email. It's going to give me back the cleaned up name, which I'll save just as name inside this loop. And then I made outside the loop at the beginning, we can see at this point, I just made a list called names. And each time I get the cleaned up name one at a time in the loop, I'm just going to append that cleaned up name to names. And then all the way at the end, even if I have a million email addresses, I can just write this function, stick my giant list in a loop, and then I can get a new list of a million names, and this function will run in a second at most. So now we begin to see the usefulness of strings and string methods in Python. Beginning to become obvious, but this is only just the beginning of what you can do with them, as you can imagine, with like AI and like Siri and Alexa and all these types of things that begin to analyze language and text. You can do a million things with this. So this is just really, the basic beginning of, dealing with text data, which might not be as obvious as dealing with, quantity and math type data, but it's just as useful. Oops. Okay, so this is what we'll begin right now, kind of the project. We'll do a couple example problems to kind of build up to the whole thing. And then just ahead of doing the actual solution of this problem, we'll skip on and do the last new content today to kind of round out the foundations of Python. And then we'll come back and with what time we have, we will finish it out if we have time. So if you haven't seen one of these, it's a basic like encryption thing that, a kid might do. So what it does is you take a plain text message like hello or something, and then you basically have two wheels of the alphabet, and you basically offset the inside wheel so that like A becomes B, B becomes C, things like that. And you can change how much you spin it by. We can see in this example, the inside alphabet got spun by a whole bunch. It got spun by like 19 clicks. So anytime you have a plain text message, A would become T, B would become U, C would become V, and so on. So you take the plain text message, kind of translate it using this wheel, and then you get an encoded message. And then when you want to decode it, you just kind of do the opposite. If you have a T, you go back to an A. If you have a U, you go back to a B, and so on. And the thing to note about this is, since the alphabet is kind of shown as a round object, when we do the alphabet, we go A all the way to Z, and then we just keep going back that way. So if we spin the inside wheel by 1, we go A to B, B to C. If we spin it by 19, we go A to T. And if we spin it by 1,000, we can do that even though the alphabet is only 26 things long, because we can just keep spinning the wheel. It's kind of redundant, but the kind of logic of it still makes sense using this visualization. And that point will be useful to us when we actually do it in code, because we'll need to be able to kind of handle that thing, that aspect of the problem. Okay, so this is the explanation again. Basically what we just said, so we can see an example. If we said hello, it might look something like this. And the one new thing on this slide is that when it will only be translating the alphabet, so A, B, X, Y, Z. If we have any digits, any punctuation, any spaces, we'll just leave that as is. So you can see in this example, I have ABC 1, 2, 3. I do translate the B, C, D, but in Python, when I implement this, I'll need some way of checking is what I'm looking at alphabetical, and if not, in this case, I'll just leave it as is. So 1, 2, 3 stays the same. Even though I kind of encode the whole thing, I'll just kind of skip that and spaces and punctuation and things like that. Okay. So what will be helpful to us, and this is just some new Python tools, which I'll just kind of teach, and then once we know what it is, it'll kind of make sense why we need it, is the modulus symbol, or the modulus operation. So I'm going to come in and actually, I'll go ahead and explain. So modulus is basically a way of doing like wraparound math. So that's why I kept mentioning if you go A to Z, you keep going back in a loop. Modulus math we actually do all the time. When you get past a specific point, you loop back to 0. And the easiest example of this is when we tell time. We begin at, this is not exactly a clock, but if we began at 12 o'clock, we go 12 o'clock, 1 o'clock, 2 o'clock. And then when we get to noon, instead of going on to 13, 14, 15, which we could if we wanted to tell that time, at least in this country, we usually do modulus to go, once we get to 12, we'll just loop back to 1, 2, 3. So we get kind of a round way of telling time instead of continuously counting up like that. We do that with time. We do that kind of with weeks. We go Sunday to Saturday, and then we go back to Sunday. We do the same thing with 365 days. When we get to 365 days, we kind of go back to day 1 and recount from the beginning. So that's what modulus is, and we all kind of already know that. Let's just see how we can use it in Python. So this is modulus. And it's basically round arithmetic. So once you get to some point, you kind of loop back and go to the beginning. So with like telling time, we go like 12 a.m. To 12 p.m. noon. And then once we get to 1 p.m., we have modulus back to 1 and begin to counting up again, instead of going on to count like this, which you would if you did, 24-hour time. Okay. So let's do some basic examples of this, and we'll just use the telling time example. So it kind of instinctively makes sense to us that we only have to deal with, one aspect of understanding it. So if we have, we'll say we have 2 p.m. So in actual time, it would look something like this. So if we did that and wanted to get back to 2, how would we do it with modulus in Python? The modulus symbol just looks like this. It's the percentage sign. So modulus is the percentage sign. And we can use it the same way we use any math symbol. So it's kind of in the same category as all, plus, minus, division, multiplication. It's just basically doing a simple math operation. So we'll want to say, what do we want to do the modulus of? And then the second thing is kind of what we divide by, what we count up to, and then go back to 0 on. So with the example of a clock, we go up to 12, and then instead of going on to, something like this, and counting time that way, we go back to 1. So 12 is what we modulus by, because we want to do the math that way. And when we see doing that, it gives us 2 back. So we do 14 modulus 12. That gives us back 2. And just kind of to keep explaining what this is actually doing, what modulus is doing, is it's basically saying, take what I want to get the modulus of, and basically keep subtracting this side of the equation until we get below it. So if we did this, it's basically doing this. If I did something like this, double that, we can see it gives me that, and that would be something like this. That example doesn't quite make as much sense with the telling time example, but that's what it'll do. So we can see what it's doing is it's simply minusing what we take the modulus of. But the useful thing about it is that if we go beyond double the 12, as in this example, if we count to day 2 and day 3 without going back 12 to 1 and keep counting up like this, modulus will automatically keep subtracting what you modulus by, the 12, until we get back to some range between 0 and what we want to get up to, so that range. So it's going to keep subtracting the 12 until we get between 0 and 12. So we can see a couple examples of this. If we do like 11 p.m. and military time, it would be 23. So if we do 23 modulus 12, that'll give us back the 11. So 2300 is equivalent to 11 p.m. If we do something like this, when we do something less than 12 and try to take the modulus of it, it's just going to give us back the same thing. It just basically doesn't do anything. So if we tried to say, take 2 and get it back to the range 0 to 12, instead of beginning with this, it just says, I'm already below that. So I'm just going to give back what I am to begin with. So that's also useful to us. So if it's something is beyond the 12, we can use modulus. And if something is already below the modulus of 12, it's just going to automatically give it back as is. It's not going to give back something else, something confusing like that. So let's go ahead. I hope the clock example was pretty helpful in understanding it. Now let's take a second example and begin to do some Python code to actually put this into practice and see how it's useful in a couple ways to us. So in this example, this is in this we'll do basically the big problem that we want to do with the Caesar shift, except instead of doing ABC to BCD and doing that, which will take a lot of additional steps, we'll just basically do a simple example of it just by encoding like a bank pin. So we have a bank pin that's going to be some digits from this set, so 0 to 9, and you just choose a couple of them to make a bank pin. And what we want to do is take a plain text bank pin that we have, something like this, and we want to encode it to be, something like this. So we want to shift it by some amount so that only if you know kind of the key that you shifted it by, can you go back to what it was to begin with. And what we'll just have to add is that shift or that key is kind of the biggest thing to know about this. In this example, we just shifted it by 1. So we took 1 and moved to 2. We took 2 and went to 3 and so on. But this could be anything. It could be 1. It could be 9. It could be, 123. And that's when the modulus begins to come in handy because we can just keep looping back around. But we'll just do one step at a time. So let's begin to set up the problem, kind of do it the simplest way, and then see how modulus comes into play and see, a true example of it. So I'm going to come in. We'll build a function, a custom function as usual. So define function name. I'm going to say I'm expecting a pin. So I'll say I'm going to accept a pin. And then I'm also expecting a second thing when I call the function, and that is the key, or how much to shift each digit of the pin by. So I'm accepting both of those. What I might do is I might give the key a default. So I'll say key equals 1, so that if I don't call the function and supply a key, the function will just assume I want to use 1 like we did in the example above. But I'm always going to expect a pin because people need to give me the actual pin they want to encode. Doesn't really make sense to kind of use a default pin if it's not someone's, actual pin. So we'll say what this function is doing in this doc string with this useful comment that I have just below my definition of the function. We want to say we want to encode a bank pin using modulus to encode the pin. I guess I already said that. Okay. And then we'll just put the end of the function. We'll kind of put the code in the middle. I'm just kind of setting up the whole problem. And then down below, I will go ahead and say, I'm going to say I'm expecting to get the encoded pin back from the function that I make. What is my function expecting? It's expecting a pin. So let me make a pin, something like this maybe, like we did in the example above. So we'll say we have pin. Let's go ahead and supply it. And I could, if I want, define a custom key to shift by, but we'll just use the default. So I'll just say just supply pin, and we'll go ahead and automatically use the shift by 1. So we should be going from this to the 2, 3, 4, 5, using this example. And then we'll just go ahead and put a little print statement at the bottom, and we'll go ahead and say pin becomes encoded. And that's using my F string, so I can make a kind of sentence of plain text and then spit out the values of these objects, these data objects, at the point that I print out this function. Okay, so let's come back in to the function, and then we'll begin to do it. So what will we need to do? We'll kind of draft it out in pseudocode. So we'll kind of set up the steps and then come back and fill it in. So if we did this by hand, what we might need to do is we say we have the whole pin, and we basically shift each digit one at a time. We go 1 to 2, write that down, 2 to 3, write that down, and so on. So to begin with, I might just begin to say, keep track of encoded pin, and we'll just go ahead and do this immediately. We'll say the code is equal to a blank string at this point. So this object is going to be updated each time we shift the pin digit by digit. Once we set up that, the main thing will be to do each digit in pin. So I'm basically writing in human language in the pseudocode, but it looks a lot like Python. I mentioned what type of loop I'm doing. I'm looping the pin, and I'll call it digits. I begin to set up something that looks a bit like Python, but it's still just kind of plain English at this point. So for each digit in pin, I'm going to shift, maybe we'll say add the key to the digit to get the new digit, the new encoded digit. And then once we get the new encoded digit, we'll just say add, new digit to code, which will save it in the thing we want to spit out at the end. And then it looks like we have, 2 basic steps. There might be additional couple Python steps, but that's good to begin with. And then down at the bottom, we already have the code to spit back out the output of this function, and we can just go ahead and fill it in. What we'll be keeping track of is code this whole time. So at the end, we can just spit that back out. So spits out encoded pin. Okay. And now we'll go ahead and jump in and fill in the Python code now that we have the basic steps in this. And as always, I'm just going to leave my pseudocode in so we can see the final steps and kind of how we planned it out to begin with. So I'm going to set up my basic loop. So again, this type of loop takes a specific object, something like a string, something like a list. It just gives me each object once. So if we have a set thing that we just kind of want to get access to each thing one at a time, we can use this type of loop. The while loop, which is the second type of loop, is when you have an unknown amount of loops. So we did that a couple times, but in this case, we'll just use this loop. Set that up. And then actually all I'm going to do is just come in. I'm just going to print out digits. So I'm just going to run the code now and see if we set it up correctly. And then we'll go on and keep coding it. So I'm going to come to my shell, Python, name of file.py. And let's see, we have a couple bugs. So it looks like we have a type bug. This is my traceback. It's going to tell me, what file, the file is obvious, and what line my bug is on. So it's saying I have the bug on this line, and it's saying I have a type bug, and int object is not iterable. And this is just a fancy way of saying we can't loop this object. We can't get access to it one at a time, one element at a time. So this might ring a bell. We've done this a couple times. This has happened to us when we've used the input function. The input function automatically gives back a string. So sometimes if we wanted to use that to get an input of something we want to do math with, we would have to do something, like this, x equals input, give, something to do math with. And then what we did last time is something like this. We needed to cast it to get it in the data type that we can actually use with what we want to do. So in this example, it's kind of the same thing. We have pin, and actually this should be pin, not capitalized if that. And what we notice is when I made pin, this is an int, and we can't loop an int. When you loop an int, you just can't do it. It's not going to give you 1, then 2, then 3. It just kind of sees this as one whole quantity, 1,234, like that. So it doesn't know that 1 is its own thing, 2 is its own thing. So what we need to do is we could do something like this. We could say pin is equal to this. So we stringify pin. So then it becomes 1, 2, 3, 4, like that. And then we can probably, hopefully loop it. So we can do that. We can also just do it, I think, in the same line. So we can kind of stack Python code. We can do it line by line, each little step by itself. But we can also just kind of do a complicated thing like this when we do 2 things on the same line. So let's fix that. Let's go ahead and see. And yep, it looks like we got what we wanted. So now that it's a string and each element in the string is its own thing, now inside the loop, I see that I get access to 1 in its own loop, 2 in its own loop, and so on. So that's how you should always plan out the pseudocode. And then as you begin to add in the actual Python code, do 1, 2 steps at a time, and then check it, see that you have what you want in the console, see that you don't have a bug crashing the whole thing. And then once you fix that step, check that step, you can move on to the next thing. So I've checked this. I can just kind of delete this line. I don't need to keep checking that, hopefully. And now let's go ahead and see what we'll do. So we'll know at this point, thinking of just loop 1, we have 1. And what we want to do is basically add key and then get new digit. So what we'll do is we'll say we want to update digit. So I'll say digit equals, and I'm going to do something on the right-hand side to change it. And what we can do is say digit plus key. So my key I have defined up at the top, that's 1. So basically just taking, in this case, 1 plus 1 equals 2. Save that as digit. And then let's just go ahead and see what that comes out to. So print digit. Hopefully we should see what we want. But it looks like we have a bug again. So let's see what that's going to do. So it looks like what we did, did what we want. This looks pretty simple, this line. Something plus something, save it back in this new object, or this updated object. But on this side, in my console, or in my shell, so we see this is the line that caused the bug, even though it looks simple. And again, we have a type bug, and it's saying can only concatenate strings, not int to strings. So let's take a look. So it looks like it thinks that I'm mixing strings in ints. And actually, that is the actual case. So what we had to do to loop the pin was to make it a string. So now that I have digit 1 at a time, digit actually, and we can check it, is not the int, but it's actually become a string. So I have 1, I have 2, 1 at a time like we wanted, but I've made them a string, so I can't do math with them. So when I check this, I can't do math quite yet. So what I can do is come back to this line that I had and say, this is the issue. This is a string at this point. So what I need to do is just re-intify it. So I made it in a string from an int, but I immediately need to go back and make it an int again. Seems a little confusing that I would do this and then immediately undo it, but I needed to do both of these. I needed to make this a string just to loop it, and then I need to go back immediately and make it an int because I wanted to do some math with it. So a little bit, confusing. It seems like it doesn't quite make sense maybe, but actually it does. It's just that in Python, we need to do all these things manually. Python, the machine, doesn't quite get, or it can't guess what we want to do. It's not human. So we need to be specific in exactly what data type it is and stuff like that. So we have this, let's check it again. And yep, we can see, actually, let's go ahead and add a little bit. So I'm going to print digit as it is to begin with. And what I'm actually going to do is use that optional end input and just put, something, a slash, a dot, something, and just so we can see what's happening. Yep, so we can see I have a 1 to begin with. I go to a 2, that makes sense, 1 plus 1, 2 plus 1, 3 plus 1, and so on. So this looks all fine. I'm just going to, I won't delete these, I'll just comment these out. So it looks like I have all that I want. And the last step that I need to do is just basically, we have this new digit, let's save it to code so we can build up the new bank pin or the new code. And then it seems like we have the whole thing, but we'll just double check. So I want to take code and say code is going to become what code was and concatenate onto that the new digit at the end of that. So I can do this line, and I can also just do, to simplify it, this. So both of these lines do the same thing. But again, this is just an abbreviation of code equals code plus something else. So basically the update symbol, we can think of it as. Okay, let's run it again. Oops. Let's see. And then we have the same problem again. So we made a string that is code. And now we want to take what we just made into an int to do the math. So this is an actual quantity digit, but code is a string that's alphabetical and text-based. So we can't add or concatenate an int to a string. So what we have to do one last time, again, it seems kind of silly, but we need to undo it again, just so we have a string and we can just make a neat bank pin just by adding all the digits side by side. So we'll go ahead and stringify that one last time, and then hopefully it'll come out as we want. And yeah, it looks like it did. Let me put these back in just so we can see the whole process. Yeah, so this is the process. Each line is a loop. We go 1 to 2, 2 to 3, and so on. This looks like it behaves exactly as we want, as we kind of explained the problem, the pin shift problem. Let's go ahead and just kind of check it. So I'm going to come down to when I call the function, and let's just supply a new pin instead. So my key is going to become 2. So let's see if the problem still fits into what we put. And it looks like we do. 1 plus 2 equals 3, 2 plus 2, 3 plus 2, and so on. And yep, looks like that comes out exactly as we want. And let's just check one last thing. We'll come to pin, and we won't always have this pin. So what happens if we have the pin of 6, 7, 8, 9? Let's go ahead and run that. And this is when we come into the issue and when we'll need modulus in a second. So we can see 6 becomes 8. Actually, let me just do that with a key of 1, so it's less complicated. So 6 plus 1 equals 7, 7 plus 1 equals 8, 8 plus 1 is 9. But this is the issue, 9 becomes 10, which doesn't make sense because you can't have a bank pin of 10, really. Each key that you type on the ATM has to be 1 digit, so it can't be 10, really. So when we think about this, it's going to be the same type of thing as like the clock or the alphabet going from A to Z and then back to A again. If we get from 9 to 10, instead of going to 10, 11, 12, what we'll want to do is just go back to 0. So if we go past 9, we go 0, 1, 2, up to 8, 9, 10, or 8, 9, and then back to 1 again. So we want to loop at this point because we don't want this to happen. We'll see a second example of this and kind of exaggerate it. If we have a key of 5 and we have a pin of 6, 7, 8, 9, 6 becomes 11, 7 becomes 12, and so on. And then my actual bank pin becomes this thing that's 8 long, and that's definitely not a bank pin at all because you can't have that many, digits in the pin. So we almost have the problem, but when we tested this case, didn't come out quite as we wanted. So let's come back into the function and use that modulus to kind of fix this issue. So we'll come into my loop, each digit 1 at a time. I'm going to come to this line, I think. So at this point, I take my digit and add the key. So 6 becomes 11. So in this loop, digit updates to 11. So this is when I probably want to use modulus to wrap around from 9 back to 0. So at this point, digit is 11 in this instance of the loop when I have it as 6 to begin with. So we need to take that and use modulus to go back to 0. So what we can do is say, we want to update digit again. And what do we want to do with digit? We want to say digit is equal to digit. And we can just use modulus. And what is it in this case? Well, we have 10 digits available to us. So that's like the example of the clock when we have 12 lines around the clock. So what do we want to modulus by? We just want to modulus by 10. So that if we go past 0 to 9, instead of going on to 10, 11, 12, we go back to 0 again. So we'll update digit at that point. And let's see what that does now. So I'm going to come back in. Let me make it simple again, just go by ones. And let's check that. Yep, so we have 6 becomes 7. That makes sense. 7, 8, 8, 9. And then 9 becomes 0 in this case because we had 9 plus 1 equals 10. But then 10 modulus 10 goes back to 0. And if we do this again with an obvious one, we'll do something like this. We can see a couple examples. We go 6 plus 2 is equal to 8. 7 is allowed to go to 9. 8 is not allowed to go to 10, so it goes back to 0. And then 9 is not allowed to go to 11. It kind of loops around the clock and goes back to 1 at that point. So 6, 7, 8, 9 becomes 8, 9, 0, 1. And now it looks finally like we have the full code as we need it. The basic code is pretty simple to set up, and it's just this little modulus inclusion that lets us handle the problem of when we get to 8, 9, how do we go back to 0, 1? And in the same way, once we get to the big problem, let me go back to it. When we get to X, Y, Z, just like 7, 8, 9, how do we get back to A, B, C instead of going on, to the alphabet that doesn't even exist? So that's how we'll handle that when we get to it. And that's why we did this little example with modulus. Okay. So this one I'm going to leave as well. So this is the classic coding problem. This is called FizzBuzz. And I'll leave it to you to do if you want, to practice a little bit. I have the problem explained. You'll be using modulus. You'll be using lists to kind of keep track of all the stuff that you have. And then obviously I have the solution in the next slide. So I'll leave that to you just to practice and just to save a little bit of time. Okay. So this is what we'll do in a second, but I'm going to go ahead and just skip on to the last new content of the class to kind of finish up all the basics that we'll need. So we'll come back to all that when we have time at the end. So I'm going to come in and just, I'll just comment out these things, and I'm just going to move all my code down so I can use the same file and not have, stuff filling up my shell with things we don't want to look at the moment. Okay. So the last thing that we'll do today is a new type of data object. So up until now, we've had the primitive data objects. So we've had strings, ints and floats. That's all the quantity type data, and bools, which is true, false. And we use with the, if, elif, and else questions, the conditions. So that's when bools come in handy. And then we have one type of kind of high level data object, collection objects, primitive data objects. One that we have is the list. List looks like this, my list is equal to that. Inside of it, we can have, anything that we want. So what it is, it's just an object that can have a bunch of objects inside of it. So we can have like a shopping list. We can have, pieces of text if we want. We can have Boolean values if we want. As you can see, we can mix values. So I can have a list of a couple quantities, some string type data, some bools, and it can even have sub lists within inside of it. So I can have a whole list, and then at the end, I can have a little shopping list kind of inside of it, like this. So that's the list that we know about. And we also know that we can add things to the end of list with append. So add object to end of list. And we also know that we can index into lists using the same kind of slicing syntax that we did at the beginning of the class and last time. So this will give us the initial object. And then obviously we know about this notation as well, just to review. So that's all the objects, data objects that we know about. We know about the basic ones, and then we know of one kind of like bucket type data object that we can fill with as many things as we want. And we saw an example of that with the taking the email addresses and cleaning them up to names. And once we get to collections, that's when we can really make a function and then stick in a list with a loop and get a list out of it so we can run, millions of data points to do things like that. So when we get to collections, that's when we can really process a lot of things at once. And what we'll do to kind of set up the last type of data object is to review one of the problems that we did last time and kind of see why we need this new type of data object and what kind of is missing from all of these type of data objects. We'll kind of see the flaw to just having these types and why we need the new one in a second. So it's going to set up an average function like we did in the last class or 2 classes ago. So I'm going to get the average. I'm going to make a blank total to begin with. I'm going to loop the list that I expect, so grade and grades. Add them all up. And then I'm going to give back total divided by, use the length function to automatically calculate how many items in the list. So we can do that. And we'll even go ahead and add one last kind of new function in just so we could see some of the built-in functions available to us. We also have available to us the round function, and that does exactly what it sounds like. It just rounds things off to decimal points. So I'll just add that in so we can see one new thing, while we do this again. So that's my function. Let's go ahead and just set up a problem to use it again. So I have a list called Tom. He has taken a couple tests. And then I can come in and you can see I labeled my list Tom. I'm going to label the output from the function as, Tom's average. And I'll spit in Tom, and then I'll print out, we'll practice an F string again. So I'll say Tom's average is something like that. And let's go ahead to just print that out. And yeah, it looks like we get what we want. So we did all that. And the point of this is to begin to look at kind of identifying data points. So when I made this, I could name it Tom. When I wanted to get the average of Tom's tests, I had to make a new data object, and I called it something specific to Tom. I called it Tom average. So up until now, we don't quite, maybe not see the flaw yet. But what happens if we have a list of all the students in the class and all the tests that they've taken? So I'm going to have something called class grades. I'm going to make a list. I can, put blank spaces, blank new lines in between. That's fine to write it this way. So I have class average. And then I'm going to put each student individually as a sublist. So I have as element 1 of the outside list, we'll say Tom. As item 2, the second sublist, I have someone else. We'll call them, just Susie. And then we'll do one last one. We'll, make some stuff up. and then we have, Sally. So I have, in this case, a list of lists, and then we can go ahead and just process that. So we can say we want to get the averages of each student in the class using this big data chunk that we have. So I'm going to say, make something called averages, get average of each student in class. I'll go ahead and loop that. So I'll say for each student in class grades, because each of these sublists is a student, I'll go ahead and say, in this loop, I'll save it as average, that of the student, just like we did above, but I'm just kind of doing it to multiple people at once now. So get the average. I'll just update that using the round function. So I'll say 2 decimal places. We'll just print it out so we can see it. And then we'll say into this, let's append it. So once we get the average of each individual student, we'll append it to the whole list of all the students. That'll be my loop, so I can outdent now, so I can leave the scope of my loop. And then I'll say, we can just print out averages to see them all at once. And then we can even do one last thing. Once we have the average of each individual student, we can come in and say, get the class average. So all the students' averages averaged itself. So we can say, something like this. And then we'll get that as well. So let's just check that it all came out. We'll kind of slow down a second since we did a lot of typing and see if we messed up at all anyway. Okay, so up to the top, let's see what we did. So we know how to identify Tom, get his average alone, and then we can print it out. We have a whole list of the class, but we can just use the loop to spit in each student one at a time. And we can see we get the average back of each. And then we also save all of those in a new list of the class averages down below. And then finally, we took 92.6, 89, and 95, averaged those, and then we know the whole class as a whole got about a 92 with all the tests that they've taken. So just a little bit of review of kind of building up from functions to the single data objects to collections or lists in this case. But now that we have all of this out in front of us, we begin to maybe see the flaw that we have. Up at this point, I could call this Tom and I could call this Tom average. But when it came to print this out, I had to specify, I had to type into this Tom's, and I had to identify this by name as well. So this isn't quite useful because if I put this kind of chunk of code in a function, what if it's not Tom that I put in at that point? What if it's Susie? How would I change this to say Susie? So we begin to see that flaw. When we come down to this list of lists, we begin to see that we don't have labels on these data objects now. Each sublist we labeled with a comment. That's kind of useful. But then once we get all of that, when we get to this point, when we get to the final result, we have no way of automatically printing out Tom got the 92, Susie got the 89, and Sally got the 95. We don't have any way of yet attaching a label to each of these sublists that we can kind of automatically do in Python. So that's the kind of drawback to what we have at the moment. We don't have the ability to label data in a useful way. So what we can do, we'll do one example of kind of the way that we can kind of get around it right now. And then we'll see the new data object, which is the dictionary. And as you can imagine, its main advantage, besides a lot of things, is that it has names attached to each data point within it. So a dictionary is just something like this. This is a collection of a lot of things, but each data point inside of it has a name attached to it. And we can use that in a whole bunch of ways. But just to begin, let's see how we can kind of cheat the system using just the list that we have now. Just to practice, some things. So let's come in, let's update grade. So we'll make a new instance of this. And what I'll do is come in and say grades. I'm going to come in and say Tom. Let me type it out, and then I'll kind of explain it and see how we'll be using it. So you can begin to see it's one immediately kind of complicated and messy looking, but we'll see how we could use things this way, because this will be good practice of indexing and just kind of getting used to seeing complicated Python. So it's going to do two of the students, so we don't have too much typing to do. So again, this is my class list, basically. And what I've done is I've made kind of the whole list. Inside the big list, I have two sublists. And then inside this sublist, I have a sub-sublist. And we can see that's quite complicated. But what I've gained now is I have Tom in the data itself, and I have Susie in the data itself. And I don't just not have them at all, or just have them kind of usefully as a comment, but not in the Python code itself like we have up above. So we kind of have it like this. Let's see quickly how we can use this to run all the averages and then pull out Tom and Susie automatically. And then we'll see once we do all that, it's going to look a bit messy and a bit confusing. We'll go on to the last data object, which will clean that all up. So I have this. Let's go ahead and loop. And we'll do this one line at a time. And actually, I'm just going to put some blank lines in between so we can kind of see it. So this is my new line. We did that last class. I just put this in so we can kind of see the gap, and this is the stuff we'll be looking at right now. So I'm looping grades. So I take the whole list and get one object back at a time, or one element at a time. So when I do that, this is element 1. This is element 2. So I get this whole thing one at a time. So what we'll need to do is kind of, we'll have to do some additional things to get Tom by itself and then get the 90, 93, 95 sublist by itself. So what we can say is we want to get the average, but we can't just stick this into the average function that we have because it's a double nested list and it has text in it, and we can't take the average of text. So we'll say average equals, we'll call the average function that we have, but what we'll input into it is we'll say, we'll take this thing called student, which is this whole thing. And what do we want to stick into the average function? Well, we want to stick the second element of this in. We just want to stick this in. So we actually know how to do that. We can just index and say, just give me, just access the one data point that we want, which is that second item in the list. So instead of sticking in student, I'm going to index into student and just stick a section of that data point into average. So I'm going to say grab student, but just grab the second item, which will be index position 1. Because keep in mind, we zero index. So Tom is index position 0. And then this whole sublist is index position 1. And then inside this list is index position 0, 1, and 2. But just thinking about the list as a whole from the top level, Tom is index 0. And then this is one element, which is index 1. Only once you go inside that sub list do you say this is 0, this is 1, and this is 2. So let's double check that. We'll say student. We'll print that out too. It's going to put a little space in between these. Oops. Just need it to save. Okay, so student again is the whole thing, Tom and the second sublist. When I just index into 1, I just get this list by itself, and that's exactly what we want. That's just a plain list, not a list within a list. So that we can stick into the average function and then get the expected output. So I'm going to do this just to get the data that I want. And then what I can do second is do what we wanted to do, which is print out the average, but automatically include the name of the student, which is built into the data itself, and we don't need to hand type out each time, which would be impossible if we had, you know, a million students. So what we can say is we want to say, you know, names average is, and then we have this, so we know this. We know what this is. This is the average. And then name obviously isn't something. So how do we access just Tom and just Susie? Well, we do kind of the same thing we did with indexing out of student. We'll come in and say, print out the value of student, but not all of student, just student 0, which is this object in the index positions. So let's check that. And yeah, we can see what we got what we wanted. So now we can pull Tom as a data object itself out of the data, as well as you know, all of his test grades. Obviously, this is a lot confusing, and that's kind of the point of the lesson, to see why this is, you know, kind of a bad way to set things up, nesting a list within a list within a list, mixing you know, test grades and names and all that kind of stuff. So if it was confusing, that was kind of the point of doing this. This is a good example of building kind of a complex data object in indexing out which bit of it that you need. But we can now leave this kind of complicated way of doing it behind and see the next type of data that we have. So I'm going to delete this just so it's not in the way. And I'm going to come up and we'll see the new type of data that we have. Okay. So it's called the dictionary. This is how you set it up, just like we would set up a list with kind of the boxy brackets. The dictionary is, you know, kind of the squiggly brackets. So that's what it'll look like. So if I set one up, I'm just making a blank one. We can see that just like if I printed out my list, that comes out just fine. If I want to check the type of it, just again to remind us of the couple functions that we have, we can see that we have this class dictionary that it is. So that's setting up a blank one, just like we would set up a blank list. And then once we want to add stuff into it, that's when it gets a little, not complicated, but just extra details. So I'm going to make a dictionary, just like we made that list of grades with a list and kind of spaced it out. We can do the same thing with this. And then the key thing to know about this is things come in sets. So you have a data object, and then kind of tied to it is some name that you give it, some unique ID. And that's key. All these things have to have unique names associated with them. So what we can do is something like this. We can say Susie, so that's going to be my key. And then my value is going to be anything that I want. So I could say Susie, colon, and then I can do a couple, you know, test grades. That's one key value set. Then I can come down and say Tom, that's my second key. Those values will be, you know, the following, and, you know, so on. So this is the basic syntax. Open up the dictionary with the squiggly brackets. You need key values. The key can be kind of anything. The keys can be, they can be strings, they can be ints, they can be, you know, floats, bools, they could be object names. They can kind of be any one thing. And then on the right-hand side, the actual data object that's inside the box called Susie, those can be almost anything as well. So values Those can be strings, ints, floats, bools, but they can also be a whole list, as we can see. They can be a sub-dictionary, as we will see, like this. Let me add a couple things. Oh, and in between each key value set, you have a comma. I space these out on 2 lines, but you could just do this. And then as you get used to this data object, you'd see, okay, I have a key. I have a value separated by a colon. I see a comma, so now I know I'm at a new key and a new value. We'll come in and just take a look at that, just print it out simply. And yeah, we can see it kind of looks exactly like we typed it, so we can just print it out and see that. So setting one up is pretty easy, just key value, all the stuff that you need. Next will be, how do we add stuff to it? How do we kind of index out of it? Just like we can index, the last item in a list. How do we now pull out, Susie's grades, or say pull out just Tom's grades in this big data object? So we'll come down. I'm going to make just a new blank one. And let's say add key value. So we want to add to the blank one. And it's going to look a lot like, it's going to look both like just making a new object, and it kind of looks like indexing notation. It just looks like those, but it's not going to be exactly that. So I say, I'm going to add something into this dictionary. So I name it. Inside the brackets on this side, I'm going to give the name of the key that I want to add into it. And then on this side, I say the value that I want to put into it. So that, again, that can be any of these types of values. So what I want to add into, the key and the value. And then we can check that down below. So you can see I began with a blank one. And then when I demo Tom equals 92, this is my new demo object. So that's adding. How can we update? So if I want to take the Tom's value that I had put in up above, how can we change that? It's kind of the same exact notation. Say Tom got a 92 on his test, but he got it back and was able to, do some bonus points, take it again, and then he got a 95. That looks exactly the same. We take demo. Instead of adding in a key value of Tom, since Tom already exists, it's going to automatically update that existing value with the new thing. And that's related to the point that I made, that each key has to be unique. So I can't have, if I have 2 Toms in the class, I couldn't just say Tom equals 92, second Tom equals 95. I would have to say, Tom S and Tom A, like this. And then you can see I have both students in the dictionary, but they have to have that unique key of Tom A and Tom S. If I just have Tom, which is the same exact string in this case, it'll delete the old Tom and update it to be the new value. So keys must be unique. If it's not unique and you do it again, it'll just update it and delete the old value. Okay, so we know how to make them from scratch. We know how to add something in, how to update something existing. How can we access a value by key? So say I have a whole dictionary of the whole class. How can I just pull out Tom's grade that I have in this data object? I'll go ahead and print this out. So I'll say inside dictionary, I want to access Tom. And if I just do this, it's just going to give me back the value assigned to that key. So if we check that, you can see Tom was last updated to 95. So that's what I get when I access the Tom key inside of demo. So that's how we can do accessing specific data points. And then the last thing that we can do, and again, both with this and lists, a lot of stuff that you can do beyond the basic things of adding something in, taking out something, and just updating. But we'll just finish with this. How do we take something out of it? How do we remove a key value like this? it can look something like this. So we'll say demo, and then it's also the pop function. That was the same with list. If you do list.pop, that's going to automatically kind of eject the last element in a list. But with a dictionary, you can't say the last thing in it. You have to specify which key value you want to kind of eject. So we'll say we want to get Tom. And then if we print that down at the bottom, we'll see what's going on. So we can see we print Tom's value, that's this 95, and then we get we pop off Tom's value, save it as removed, so that's this 95, and then if we print out demo, we can see the Tom 95 has been deleted from the list, so now the list is back to empty. One thing to note is we can do the same thing. So if we did something like this, just so we know absolutely. And let me just highlight this line. So if we want to access Tom's value, we can just do this. We can also save it in a new thing called X. So you can see I have Tom's value, which I saved. I kind of looked into my dictionary, looked at Tom's value, put it in a new thing called X. But unlike when we popped it, I still have Tom 95 in my list. So I kind of made a copy of the value that I can, use someplace else, but I haven't taken it out of the list as such. So this line is a bit different from this line, though same kind of principle, accessing the value. But in this case, we don't delete it. In this case, we do delete it. So that's all the basics of, adding, making, deleting, accessing a list. We still have some basic stuff that we need to do. We know with a list, it's pretty simple to loop them. And hang on one second, I'm just going to comment that out. So with the list, we can just loop it element by element, but how do we loop a dictionary since we have keys and values that we need to juggle? So let's make something. So it's going to make a simple dictionary. And you can see the spacing between things doesn't really affect anything. I can't have a space. I don't need a space if you want. So I sent up demo to that object. And let's see the couple ways that we can loop a dictionary. So one way to loop a dictionary is just to, if you just give the name of the dictionary, you can just get back the key. So I have key of A, value 1, key of B, value 2. When I loop just demo 2, that by default gives me back just the keys. So this one is just keys. An additional way that we can loop a dictionary is to get back both the key and the value, as you expect you might want. So this looks like this. Bit complicated, a new thing in it, but it's just something you need to kind of get used to and memorize. So we kind of have a 2-bit thing with the loop. I take demo 2 and I use this built-in function, which basically just says take demo 2 and split it down into the couples of the key and the values. That's what this .items is doing. It's built into Python. You don't need to know too much about it. And since I get back both the key and the value at once, I need to give 2 names. So I just assign my own names. You don't have to use key and value, but I say I'm going to expect a key and expect a value with each loop of this. So that's how I can get back both the key and the value at once. So that might be useful when we want to apply it to the grades that we had. I think I did that. What happened to me? And then finally, the last way is if we just want the values, say we have a list of all the students and the grades that they have, we kind of want to ditch the names and just kind of get the whole maybe school average. So we don't need the names, which is the keys. We can just get back those. So we can say for value in demo2 dot, and then this one is just called dot values. And we can just print that out one at a time. And then we get back just the values, and we don't pull the keys out of demo2. So this data object adds a lot of complexity. You can do a lot of things. You have a couple things you need to memorize, depending on how you want to use things. But we can see the usefulness of it is that now data has labels. So if we have a whole school, we can keep all the data in one giant dictionary. We can have, the names, the grades in each class, stuff like that. In this next example we do, sometimes when you begin a Python program, you might get data from something else. It's not going to be in the way that you want it. So you might get two lists, one a list of names and one with a list of the relative grades of those names. So John is 92, Jill is 95, and so on. So we'll do a couple things to see how can we combine these into one new data object. So John is tied to 92, and things like that, depending on how you begin. So we could say we want to combine these. So we want John as a key, 92 as its value, Jill 95, Susie 93. So we'll use the new data object that we have. So we have a dictionary. We'll just set up a blank one. And now what can we do? How do we access John and 92 one at a time? Well, we kind of know how. We can do something like this. If I just print that out. Oops. We can see I know that they both have the same position. So John is tied to 92, and I just use these index positions. But how can I do that automatically? I don't want to do this for Jill and Susie, let alone 1,000 students that I have, type this out by hand. How can I get access to these kind of index positions using some, code to do that? So what we can do is we'll set up a loop, and we'll kind of think about this logically. We need the index positions 0, 1, and 2. So we want to loop that many times, and then once we loop that many times, we can use those index positions within each loop to access each set, John 92, Jill 95, and so on. So I'm going to say for index position in, and then I want a range. So I could just do 0 to 3 to get my 0, 1, 2. But again, that's not dynamic. If names becomes a list 1,000 people long, I'd have to come back and modify this code. So instead of putting in 0 and 3, what I can do is say I want to define my stop position. So I don't need to say begin at 0, though I can leave it if I want. How can I dynamically get the length of these two lists? Well, we know how to do that. I can just stick in length of names. Length of names is 3. So if I do something like this, that's going to give me something like this. And then I have these index positions in the loop called index, and I can do this kind of thing to get John and 92 one at a time, Jill and 95 one at a time, and so on. I could swap this out and put grades instead, but it's the same two lists. They should have the same amount of items in each. So I kind of just, picked one. So now we can come in. Let's take this, stick it in this, and then instead of the 0, we'll say, well, we want to index with index position, what we called index. And let's see if that comes out as we want. And it looks like it does. So we get with this loop 0, 1, and 2. One at a time, we do name 0, grade 0. That's John 92. That matches up to how we set up the data. On the next loop, we get access to 1. So then we get names 1, grades 1, and then the same with the last one. So this is how we can kind of use a bit of fancy math and a couple things stacked up, indexing, the range function, the length function, to do what's kind of a simple problem, but it takes some thinking to do in Python. So this is how we can get them. But now that we have access to them, let's actually save them in this thing called new. So I know I have access to all the data points that I have, one at a time. So what I can do is say new, and then I can say, and again, this is going to look a bit ugly. Let me print it all out, and then we'll go back and explain it. Just double checking that I didn't mess up. Okay, so we did this line. We know that we have John and 92. So what I did is say, add a new key to new. So this is my adding a new key to new. And then what is my key? Well, it's kind of stacked and it looks a bit complicated, but my key is names at index position. So names at index position 0, 1, and 2. So that's how I get my keys down below. And then my value is just going to be grades at the index position of each loop one at a time, 92, 95, and 93. And we can see we successfully kind of zipped up all the data into one new data object instead of having them in two separate ones. So the useful thing about this is now that we have we have the values attached to the names in one place. The second thing is that if we kept the data as two data objects like this, it could quite easily happen that we maybe append a data point to grades, but we neglect to add a new name to names. So that would make names not as long as grades. So that would mess things up, and it would kind of offset everybody. So Susie would have Billy's grade, Billy would have Samantha's grade, and so on. So that's why it's best to have the data all in one concrete object instead of using this obviously complex notation to do that instead. So if we have something like this, we'd want to zip up the data into one new thing, and then we can just easily access it all at once. This is kind of the complicated way. That was good practice to do this. We can do the same thing a little less complicated, zipping this into one new data object. So to do that, it would look something like this. So if we look down below, look at this side of it. The zip function is a built-in Python function. And what it does is it takes two lists of equal length, and on each loop of the list, it gives you the matching two items. So on loop 1, it gives you name 1 and grade 1. On the second loop, it'll give you name 2 and grade 2. So it basically does exactly what we did up this way manually, but with a lot less of this complicated notation and doing the manual indexing like that. So we zip them up, and then we get access to one item out of each at a time. And then we need to do the same thing. So since we have two items in hand each loop, we get one name and one grade. So we need to do this thing just like we did up above when we loop a dictionary and get the key and the value. We need to do the same thing down this way. We get the name and the grade that zip gives us. It gives us two things at once. And then down this way, we can do the same thing, but it looks a lot less complicated, quite easy. New. And then we've done the same exact thing, but once you begin to add in these built-in Python functions and different skills, what you would previously have to do, manually and quite complicatedly, you can do pretty simply once you have these in the toolkit. 。 Okay, we'll do one last thing with these. This will be some practice again. So in this case, we will make, let me call this school actually. So as you've seen, lists can have a lot of things. Dictionaries can have a lot of data in it as well. So I'm going to make a dictionary called school, and it can basically be all the data of a school at once. So we'll kind of see how to build kind of a complicated data object using the dictionary and how to kind of access and index into it. So say we have school, let's say we have something like grade 8. We'll just kind of set up the levels of this. We have grade 9, we'll say 10, 11, and 12. So I have a dictionary. Inside of these, I have a key of 8, that's 8th grade, and inside 8th grade as its value is a sub-dictionary. And then I have 9, 10, 11, 12. But let's just focus on one. Let's go inside of 8, go inside the sub-dictionary, and let's go ahead and kind of make up you know, all the data contents of like a single student that's now in 8th grade. So we'll say we have Jane as a key. We'll say like Jane, you know, A. She's someone, so she has a sub-dictionary. We have Bob B. He also has his own data contents. And we can keep going and have all the students in grade 8. And then we could keep going in this and do all the students in grade, you know, 9 and 10 as well. But again, we'll just focus on one student at a time. And we can begin to see, we begin to nest quite deeply, something inside something with inside something. So Jane A, we'll say like each student has a specific, you know, like student ID that they have. So we'll just make up one. We can say this is still Jane's data, so we'll stay on the same level. This is a second key value within Jane A. Just put all kind of the, you know, the private details about Jane, address, you can see we can do different types of data. So now I have a Boolean type instead of a string data. I can say, you know, what prizes, academic prizes has she won? And then now I can do something like a list instead. So she got this one. She got a second prize as well. Something like that. And notice I'm adding a comma to the end of each whole value. So I had this list as the value of this key, but at the end I need to comma to go to my next key value within Jane A. Then we'll have grades, and then we'll just go ahead and quickly add the comma to the end of that. And hang on a second, I think I just missed something. Oh, I'm missing a comma, I mean a colon. So I have grades. And inside of this, we'll do something within something within something. So I'll come inside of 8th grade, come inside of Jane A, get inside my grades object. And inside of this, I can begin to say, you know, what did she get in science? What did she get in gym? Different classes, and so on. And so we can nest these things as deeply as we want, have all the data in it that we need. This type of thing is a lot analogous to something called JSON data, JSON. And this is the type of thing, this is the type of data object that websites use a lot. So when you use like APIs to have one website access something on a different website, and you have websites communicating, this is how they send data packages. They have a huge data object, in this case called school. And then inside of that, they have a key, and then values, key values within key values, and so on like this. And then the receiving website can say, I know what keys might be in this that I'm expecting, so let me grab the values that it gives me. And so it knows what keys to use, and it can get the updated data depending on what API that it's using to get data website to website. So this one is quite big. Oops. Let's take a look at what it looks like. Oops. So you can see when I print it out, I get the whole thing like that. Let's practice a little bit indexing into this, pulling out specific stuff that we need. So let's say we want to get, Jane's grades. How can we pull that out of this whole thing? So we can kind of stack this up. So we can say we want to access something out of school. That makes sense. So I'll say school, and I want to access by key. So to get to Jane, I need to go into 8th grade. So I'm going to say school, just give me back 8th grade, or print this out so we can kind of see it as we do it. Oops. Let me add a comment. Get Jane's grades. Okay. So I access school. I just want to go into 8th grade. And then when I go into 8th grade, we can see I get all of Jane A, but I also get Bob B and anyone else, which is within all of 8th grade, which is this whole thing. So let me keep going. And I can actually just keep stacking on my kind of key value indexing in. So on top of going into school in just 8, I'm going to just access Jane A. And I want to match this exactly. So Jane A dot, let's see that. So now we can see I skipped from Jane A and Bob B and all the students at once. And now I'm just inside all of Jane's the data. So now I'm just at the Jane level. And I can keep going and just keep stacking stuff up. So now I'm just at the Jane level. So I'm at this point. And now what do I want? I want the grades. So I can come down and say, just give me back the grades like this. And then we can see I've done all of this just to get to Jane's final test grades. So complicated data objects that you can build takes a bit to kind of key into them. But once you get the concept, it'll be quite useful to you. We'll do a second example. Let's say we want to see what prize did Jane get, but just like the initial prize that she had gotten. So we can say something equals something, print that out at the end, and we'll kind of do the same thing. So we'll say school. We know we want to go into 8. We know we want to go into Jane A. Let's check that real quick. I just had that. Okay. So I'm just looking at Jane A stuff. So I have all of this. This looks like what I need to key into. So I can add one less key onto the end. And now we can see I have just that list. And then how do I get back just the initial one? Well, let's take a look at what we have in hand. So I'm going to print out the type of what I get back. And we can see that's a list. When I index to this level, I just get back this value. So I just have a list in hand now. So this whole thing gives me back a list. So I could do something like this. Take that list and just index in to get the initial prize of that list. And you can do it that way. But we can also just do it this way as well. And this is when it gets a bit... oops, what did I just do? Okay, like this. I'm messing myself up now. Okay, so we have the list. That's what this is. We know it is a list. We know it's a list. We can index once we have the list in hand to get that, but we should be able to do this, and I don't know why it's not doing it. Oh, okay, okay. Okay, so we could just do this as well. Since this becomes a list, we can add this onto the end of it, which is not a dictionary key. It's now a list indexing. So I can have these two things kind of side by side. So this is a dictionary. This is keying into it. This is keying into it. This is keying into it. But now that I've gone this whole way, I now just have a list in hand. So when I add this index notation at the end of it, it actually is indexing out of a list and not a key into a dictionary. So we can kind of have those side by side like that. Keying into dictionary plus indexing into list side by side. I apologize about the confusion. Okay. But the main thing about this is to begin to see this is the kind of data objects that you might have, beyond simple practice. It can get quite chunky, and then you will have to do things like this to pull the data out and do what you will with them. This is in the handout as well if you want to not type it all, obviously. Okay. So we'll not do this now. We'll go back to the encryption function in a second. But this is one last project, not a project. It's not that complicated. But one last practice problem that you can do if you want to practice all that we've done in this class. So now that we have the dictionary, we can have keys and values. So when it comes to doing something like getting the points of a Scrabble games, a play in Scrabble, it's now possible now that we can have the key of all the alphabetical tiles and the value of all the points of A and B and J and things like that. So in this function, what you'll want to do is use the input function to get the two plays of two people. And the point of this one is to say who wins. Again, between two plays, someone plays Ribbit, someone plays Frog, who got the most points and who is going to win. So a couple things going on. You'll want to use input to get what is P1 play, what is P2 play. And then once you have Ribbit and Frog, you'll want to do a bunch of things to loop Ribbit, count up all the points in it, and you'll do that accessing the dictionary, saying how many points does I get, how many points does B get again, E and T, and so on. So that's how you'll get the points, add them up, and then at the end, you'll say you have the points of Ribbit, you have the points of Frog, and just do a simple conditional check to see who had the most points and how to print out who wins, as we can see down below. And I have the solution all the way at the end of the handout. And then the last thing I want to do ahead of going back to the problem in the middle of the class is going to be just pointing out the couple things that you can go on to do and practice and keep studying now that today is obviously the last class. So I have all these in the handout, but I'll just show you what they look like so you can get an idea of what these sites look like. So one, I think we've seen most of these, but one again is W3 School's Python introduction lesson. It just goes, topic by topic. Within each topic that you go to, they kind of explain what's going on. They have code boxes that you can see the examples of, get taught the lesson, and then you can pop them open and, do actual Python to practice a little bit and do stuff to what they taught you. looking at the left-hand side, you can see a lot of the things that we did, we see on this. We see the variables, casting, strings, booleans, lists, tuples, and sets. That's the last two type of data objects in the collection box. So we have the dictionary and we have the list. And then you also have tuples and sets as well that can both hold multiple data objects. But we skip those because they get a little bit less used. So we just didn't have the time to do them. You see the loops, functions, and then down at the end of the introduction that they have, they get to a lot of things that we didn't quite get to because of time, classes, scope, and all these, kind of complicated things. Regex, that's something that you use with string type data. So that's what I was talking about when we go into the play of Hamlet and we want to break down the string object, which is all the text of Hamlet, and break it down into each individual line. How would we do that? You would do something like tell Python a trend to find. So you couldn't tell Python break the text at this exact point each time because it's going to look slightly different. But regex is a way of kind of defining a trend of text. So you could say find any capitalized name followed by a full stop followed by a new line. Always find that type of data, and then you can do something at that point, split up that string into a list. So that's what regex can do, all types of text analysis. And then down, all the types of, advanced Python into AI and, data analysis, advanced math, things like that if you need it. But really the introduction Python ends, down this way. The SW3 School's good thing to practice if you want to, do everything we did again and see what we didn't have time to. This website we saw once, and I'll just show again what it's doing. This website is useful if you write a bunch of code and it's running into a bug and you can't exactly find when and how the bug is happening. So you can paste the code that you have into this website, and then it basically lets you execute the code basically one step at a time. And it's basically always going to say, what's the value of each object that you have? Which line is Python looking at when the values get updated? So you can see this is the console, but then it's also showing you the exact value of each thing as you go. So if you get into any bugs, you can come to this website and see, oh, this object is not behaving as it should, because you can see kind of the invisible value of it that you wouldn't see unless you printed it out. So this site is good as well. This site is a good practice website. You can make a free account, and what it basically is a way of practicing. So it's going to give you example problems. I just gone into one example problem. So it's level 8. That's the easiest level. Level 1 is the most challenging. Simple problem, calculate an average. We've done this a couple of times now. It kind of gives you the instructions of what to do, some notes on what should happen. And then in this box, you can execute the code. So on this side, I have the same thing. And you can see I just put my code into it. I push the test button, and then it shows, did I pass the test? Did I fail in some instances? So this is a good site as well. And then once you attempt it and finish it, you can submit it, and then you begin to stack up points, and then you go on to the intermediate and challenging questions. And then the last one I want to mention is Real Python. This tends to have like medium to advanced lesson plans that you can access. Some of it is behind a paywall, but like a lot of it is freely accessible. This one is on how to web scrape with Python. And you can see it's quite a lengthy lesson. So it's good that it'll say, define everything, give you the exact code. Let me move down to the code, give you the exact code to do things with examples. So if you want to study any advanced topic, come to Real Python. It'll tell you how to download and install things, the code to set up an example of it, and all the stuff with it. So this also is a good site once you get beyond the basics to go back to. Okay. So let me go back in time to the encryption. And we only have 12 minutes left, so we won't do the solution, but we'll explain it again and set up the problem with a couple hints. So again, back to this, A to B, B to C, C to D. Same thing with the pin shift, but instead of shifting digits, we need to shift the alphabet, basically. So let's go ahead. I'm going to make a new file. I'm going to do touch. I'm just going to make a file that just has this in it. And we'll just begin to set it up and maybe just block out the pseudocode. Okay, so I have my function. I'm just going to put a doc string explaining what it is. So it takes a string as input, gives back as output the string encrypted using the given key. So that's what we want to do. So we'll go ahead and keep kind of setting up this function. So what do we expect? We want to expect some message. We'll call it plain text. And we'll also, just like the pin shift, expect some key. So people can define exactly how much they want to, shift the wheel by. Just shifting by 1 might be a bit obvious. So you can choose anything you want, choose 19, and so on. Key, again, we can just define a default. So I'll just say key equals 1 just as the default. And then when we call the function, we can do that down below. And then we'll go ahead and do the pseudocode. Okay, so we have this all set up. And now let's kind of talk about how we might go about doing this. So same kind of steps as the pin shift. Although in this case, we have a couple additional steps because again, it's not just digits like a bank pin, it's the alphabet. So we don't have an easy way of just adding 1 to A to get to B. So we'll have to think of some way of assigning, 1 to 26 to the alphabet so that we can kind of maybe index into that to kind of get those letters of the alphabet. So what we'll need to do, again, just the way we set up the problem, we need to, check that is actually, we'll say step 1, we'll loop the plain text. That'll be obvious. We want to get access to A, then B, then C, 1 at a time, so we can shift each one individually. So step A is just going to be loop the plain text probably. Inside of that, what we might just do is, and again, we'll go back to the kind of idea of the problem. We don't want to shift anything like spaces, punctuation, digits. So in this example, we shift the ABC and the XYZ, but not the 1, 2, 3, and anything else that might be in it. So ahead of doing any of the shifting, we might want to check that. Instead of saying check, that's the same thing as saying if. So if it's alphabetical, then we'll do some stuff to it, but else. So we've kind of skipped a couple steps. Most of the problem will be inside this block, because if we get to this point, what we'll just do is, something, like this. We'll just add it back to it. In this case, it would be something like 1 to, a dot, a blank space, stuff like that, that doesn't get shifted based on how we set up the problem. So once we go inside of this, then at this point, we need to think about how we'll do this. So instead of taking 1 with the bank pin and adding 2 to it, if we shift by that, how do we add, a key of 2 to A to get to C? Well, we can't do it just using the alphabet. So one way we might do it is to come back in, and up at the top, we'll kind of need to make an alphabet that's tied to index positions. So we could do that with dictionaries. Now that we know about them, we could say like key of A is value of 1 and so on. But the easiest way might just be something like this. So we'll say like object alphabet is equal to, and then we'll just type out the whole alphabet like that. And then the idea behind just typing out the whole alphabet is that we can kind of do math with this because we can index into the alphabet. So these automatically have positions tied to them because we can index into it. So each of these have a 0 to 25 attached to them. So that'll be useful to us when we want to shift by 2. If we have A and we want to get to C, jumping by 2, we can somehow say we have A, its index position is 0. We'll need to find that some way. Once we have the 0, we can just add 2 to it. So we go A to 0, 0 to 2, and then we just need to index back. So we'll say, what is the index position 2 inside of alphabet? Well, that's going to be C. So that's how we can do that without a dictionary. We can go A to 0, 0 plus key of 2, 2 back to C, all using indexing. So that'll be the alphabet that we have up at the top. Obviously, you'll need to type out the whole thing, and then we can use that like that. So down this way, we'll go ahead and do that. So we have the plain text bit by bit. We begin with the A. So what we'll say is get position of the thing we have in hand. And as an example, we'll say A. What we'll want to do next is add key to index position. So we have a 0. So we'll want to say 0 plus 2. And then once we have the 2, we can say index back into alphabet to get the new thing that we want. And that'll be, C in this example. Once we have that, we can do, the obvious step of saying add to code what we just encrypted. So again, that C that we pulled out. And then this is the basic outline minus a couple things that you might run into. One, we did that whole thing about modulus. So obviously that's going to come into play at some point. So if we take a look at this wheel, we can get to A from A to C by adding 2. But what happens if the plain text message is W and we have a key of 19? We would have to shift from W back to A and so on. So we'd have to loop around. So at some point, just like pin shift, probably at or about this point, we might need to use modulus at some point. Use modulus to wrap around from Z back to A, B, C. So if you go past Z, nothing is past Z. Obviously, so you need some way of going from Z to A, B, C. Z is index position 25, so you need some way of going from 25 back to A, B, C, which is 0, 1, 2. The modulus is probably going to be something like that, since, a clocky modulus by 12 with 26 actually. With the alphabet, it's 26 long, so to go back to the beginning, you modulus by 26. So this will probably come into play. And then a couple things that I'll just add at the bottom, which might be useful to you. You'll see when it'll be useful is the following. So I'm going to give you just a list of functions which might come in handy. So obviously you'll use modulus. Length might come in handy. Is alpha might come in handy. So is alpha is a built-in function. Looks something like this, and you just give it some input, and if it's all alphabetical, that gives back true. But if it isn't, or some of it is not, like in this case, it'll give back false. So that could be helpful when asking, when to encode something, or if it's a 1, just skip encoding it completely. So is alpha could come in handy. Type could come in handy. And then a new thing called is instance. And what is instance, what it does is kind of like type, but instead of giving back the type, what you do to use it is you say is instance, give it some data, and then as the second input, you say what type of data do you want to see if it's an instance of, and if it is, you get back true. And if it isn't, so we'll say is instance, hello, is that an int? It will give back false. So that is instance, and that could also come in handy. And then finally, we have these functions, which also might come in handy when dealing with capitalized things and not capitalized things. So we saw in the beginning with strings, things need to match exactly. It is case sensitive. So you might need to deal with seeing if something is capitalized, or actually capitalizing something if you need to. So I'll leave these down below as well. So these capitalize lowercase, and then these give back true, false, depending on if what is inside is all capitalized or not. So these might all come in handy. And I think that's all that you might need. And that should be good enough to finish the problem. And then one thing I'll mention is, let me pull it back up. All of these functions that I just gave you, you can look these up in W3 School. So I just Googled, let's see if I did Google it. I just Googled Python is instance if you want to fully see how to use it, if my explanation wasn't enough. W3 Schools usually pops up at the top. This is also a good website, but if you pop into this, it'll give you the example. You can test it out, kind of explain the whole syntax, and see all the examples that you might want to. So if you come across something you haven't used, you can head on to W3 Schools to fully see how to use it. Okay, so that's what I'll leave you with, this little blocking out of the steps. And if you want to, obviously, you can go ahead and fill it in. Go step by step, do a couple lines of code, even one line of code at a time. Print it out, play the code to see if it comes out as you want, and then you should be able to get to the end. And obviously, I have the solution in the handout as well. Okay, so I'm going to go ahead and pause the